Today we're going to make some cables up. My shipment from Aircraft Spruce has finally arrived, and I can finish the cables on the back end of the aeroplane here. And what we're going to do, wait for that to focus, is we're going to have a little look at what we've got here with the thimble, this ferrule, and how it's swaged. This is just a piece of heat shrink plastic. Some of you will argue with me that you shouldn't use heat shrink, and I'll agree with you on galvanised cables. These are stainless steel cables, and this just stops you from getting bitten when you go anywhere near these. With if it just had loose strands of stainless steel sticking out, it would be a bit awkward. These are some of the things we're going to be using. We need obviously some cable. This one, if you can read that, which I sort of doubt, but it's basically 532 stainless steel cable with 7 by 19 strand. That's 532. This one's 332, and the one that we just looked at on the aeroplane was probably 1/16. And of course, to match the cable, you need the correct size swages. These ones are 5/16. They're copper sleeves, which is 18-4-P. The P is sort of going to be important in a minute. These ones are 18-2-G, and the G will be important in a minute. These ones over here are 1/16, 18-1-C, and the C is important. Now, if we go over here, we'll have a look at that tool in a minute. But if we go over here and have a look at this list, which you may or may not be able to see. If I bring it up here, you might be able to see it a bit better. These are the, no, we need to have it that way. These are the oval sleeves that we'll be using. And I've circled the 3 different sizes, 1/16, 332 and 532. They'll tell us that's the size of cable. There they are, just as they were written on the cable itself. 18-1-C, 18-4-P, and 18-2-G. Okay, well, what does that tell us? This tool here, which is fairly big and heavy and reasonably expensive, has, let's see how we're going to be able to see this. Maybe that way? Maybe. But these crimps on the end, or the crimping jaws, this is a P, this is an M, this is a C, a G, and this is a C. That letter that was that I said would become important actually tells you what size jaw to use for what size sleeve. And over here in this right-hand column, it tells you how many presses. These 2 smaller ones, the 1/16 and the 332, are 1 press each. Yeah, 1 press on a G jaw, and this one has 1 press on a C jaw. This one, the P, has 3 presses, if you can see that. I can't see it very well through the viewfinder, but hopefully it'll show up. There it is there, in fact. 3 presses. And it tells you further in the document where the presses are to go and that sort of thing. But there's another document that I use that tells you how to do the presses. Once we've pressed a swage onto a cable. We then use this go, no-go gauge, which has appropriate markings on it as well, here and here. It's upside down, of course, that'd be right, but you can't see it very well anyhow. Yeah, it has appropriate markings, which once the sleeve has been swaged, this device should actually go over the top. It'll be like this. The sleeve will fit beautifully in there, but it needs to fit the other way. And when it's been squeezed sufficiently, it will fit in that jaw there. Yeah, pretty straightforward. But if you haven't seen it, it can be a little bit tricky and a bit daunting. So let's see if we can't do one, see what happens. Before we get started, we need to have a little discussion about turnbuckles, I suppose. This turnbuckle has a fork on one end, which takes a clevis pin, and just a loop on the other end that takes a thimble and the actual cable. That stainless steel thing's called a thimble, and of course the cable, this is 1/16 cable, is threaded through it. Now the way turnbuckles work is if you constrain both ends of it and you turn the barrel in the middle, it'll either get longer or shorter. And it will do, it'll go it's got a lot of range of movement, put it that way. When all's said and done and it's all locked up and finished and in the final resting place, it will have no more than 4 threads protruding from the end of the barrel. I'm pretty sure it's 4 threads, but you need to look that up. You can't have it with just hanging on by a couple of threads, because this thing's brass and those threads will just pull out. So that when you turn the barrel it gets longer or shorter, you need to have one end of it threaded left-hand thread and the other end threaded normally right-hand thread. The way almost everything in aviation works, if it's left-hand anything, then it's identified. And if you have a look here, this end of the turnbuckle is identified with this mark. There's no corresponding mark on the other end. That shows you that this is the left-hand threaded end. So it just turns the opposite way. Yeah, so constrain it, turn it, and it'll get longer or shorter. Beautiful, simple thing. You just need to see it once. Now, the way I do this is I've wound the turnbuckle so that there are no threads sticking out either end. I've put the thimble on and I pull the cable up as tight as, reasonably tight by hand. Push the copper sleeve down as far as I can, so it sits down like nice and tight like that, and then swage it on. This is a C-size swage, so on this tool, it's the smallest one. The smallest jaws are the C jaws. Let's see how we go. I've decided to totally redo the swage. I'm not happy with, I wasn't happy with that one, so I'll make a whole new cable. Here we are back at this is the other end not the end I was trying to do, the other end. We'll do it here. It's a lot easier to do on the bench than halfway in situ. Yeah, basically get it in the middle. Believe it or not. hopefully you see what I'm doing there. Yeah, should be hard up against the thimble like that. And then into the jaws like that, and down we go. Trolley going all over the place. Let's have a look. Okay, that's not quite what I had in mind, but it's tight. I will do this, the back end again. It needs to be all the way down. Yeah, that's not correct. But the rest of the swage looks pretty nice. So it wasn't in the middle of the jaws. Now it is. Quite easy when you've only got to do that last little bit. Okay, that's quite acceptable now. I've no issues with that at all. I'll get it around here where you can see it. Be nicer if we had some light there as well, I suppose. But that's it. We've just got this end piece that we've got to deal with. Now, something I didn't discuss is how to cut the cable. Now, if we used just like a pair of angle cutters or something like that, you'd wind up with strands all over the place. You would never ever get that heat shrink over there to make it look nice and neat. But to the rescue is this special tool here, which cuts the cable. It's just a little parrot beak sort of cutter, but it cuts the cable really, really well. We put that in probably about there. Now, can we see that anywhere? Not really. It's horrible whichever angle we go on. But there it is. That's all it took. Believe it or not, that just cut perfectly. Yeah? You need one of them. Seriously need one of them to cut your cable. And that little tool will cut these big 5/16 ones just, not quite as easy, but just very, very easy. There's the heat shrink is on, and we're almost back to where we were before I started the whole exercise. Oh, no, we didn't, we haven't checked this against the go, no-go gauge yet. Stand by. Here's one that I just happened to have prepared earlier, and we want this one that says Oval C. It's the smallest one on the bottom there. So we come in and look at that. It's got to be at least that size. It could be firmer fit than that, and that would be okay. Yeah, but if it can't go in there at all, then obviously the swage isn't compressed sufficiently. These copper swages really deform into the strands of into the weave of the cable, and they ain't going anywhere. You would break something else on the cable before those swages would let go. They are really, really strong.